The universe has always been a subject of intense curiosity, with its vastness and complex phenomena captivating scientists and astronomers for centuries. From the formation of star systems to the presence of dark matter and dark energy, decades of research and observations have provided us with insights into the formation and evolution of the cosmos. However, a recent groundbreaking discovery by the James Webb Space Telescope, JWST, has left scientists perplexed, challenging our current understanding of the universe's development and even defying one of the fundamental laws of physics. This revelation is so significant because it contradicts the established models of cosmology, raising questions about the very foundations of our universe. What exactly did the JWST uncover? And why is it such a game changer? How does this discovery affect our existing cosmological models? And what does it mean for the future of space research? In this video, we'll explore how the JWST's latest findings could shatter our understanding of the cosmos and the laws that govern it. Understanding the universe's origins has always been crucial to humankind. The desire to uncover how the vast expanse of space came to be sparked the development of fields like astronomy and cosmology. Thanks to these disciplines, we've learned a great deal about the universe, from star systems to cosmic phenomena. For example, we now know that the universe is not evenly distributed. Some regions are denser than others, which has led scientists to support the Big Bang theory. The Big Bang theory is the widely accepted explanation of how the universe began. It suggests that the universe started as a singular point, expanding and cooling over time to become the vast expanse we see today. Supporting evidence for this theory includes the cosmic microwave background, CMB, which is the residual radiation from the Big Bang. This radiation has been present for over 13.8 billion years, carrying valuable information about the early stages of the universe. Over time, our theories about the universe's development have evolved, thanks to new discoveries and more advanced tools for observation. These breakthroughs sometimes challenge the current models or lead to the development of entirely new ones. However, what happens when unexpected and unexplainable events occur? These anomalies force the scientific community to reconsider if we've missed something fundamental, or if there's an unknown force at play. The James Webb Space Telescope is a cutting-edge instrument designed to explore the universe like never before. JWST has not only provided stunning images of distant stars and galaxies but has also enabled us to peer further into space, pushing the boundaries of our understanding. Its primary mission was to observe the farthest reaches of the universe, capturing the formation of stars and galaxies moments after the Big Bang. By studying these distant objects, researchers hope to gain further insights into the evolution of stars, galaxies, and planetary systems. In addition to exploring the universe's distant past, JWST has revealed other intriguing concepts like dark matter, dark energy, and the expansion of the universe. The theory of cosmic expansion, for instance, suggests that the universe is constantly growing, with galaxies and galaxy clusters moving away from each other. This ongoing expansion is thought to be driven by dark energy, a mysterious force that is still not fully understood. Scientists also believe that dark matter, an invisible substance that cannot be directly observed, makes up a significant portion of the universe's mass. Over the years, researchers have developed several methods to detect or measure dark matter, but until now, there has been no conclusive way to identify it. Thanks to JWST's advanced imaging capabilities, astronomers are now able to better map out the distribution of dark matter across the universe. One of the techniques used is gravitational lensing, a phenomenon where massive objects bend the fabric of spacetime, causing light from distant sources to distort. By observing the effects of gravitational lensing in JWST's images, scientists can estimate the amount of dark matter in a particular region of space. The ability to directly observe these phenomena has been instrumental in testing and refining our cosmological models. Despite all the success JWST has brought to the scientific community, its most recent discovery is one that has left researchers bewildered. While the telescope has made numerous groundbreaking observations, including the detection of planet-like objects within the Orion cloud, a region that had been previously obscured by dust, there's one new finding that is truly unsettling. The JWST recently uncovered a shocking and unprecedented event. Over 771 trillion planetary systems have mysteriously vanished from the universe. This means that trillions of stars and their associated planets have disappeared without a trace. This is not a normal occurrence, and it's something that has never been observed before. Furthermore, this disappearance challenges one of the fundamental laws of physics, the law of conservation of matter, which states that mass can neither be created nor destroyed, only transformed from one form to another. Given that much of our understanding of the universe is built on laws like this, scientists are struggling to explain how entire planetary systems could simply vanish. Did they disintegrate, or did they somehow move out of observable space? Some researchers have proposed a potential theory. Perhaps these planetary systems are in the final stages of transformation, where their mass is changing into something else. However, the details remain unclear, and this mystery has sparked a heated debate within the scientific community. In conclusion, the recent discovery by the James Webb Space Telescope has raised more questions than answers, leaving astronomers rethinking the very foundations of cosmology. The sudden disappearance of trillions of stars and planets, coupled with the apparent violation of the law of conservation of matter, has shaken the scientific world. As new data continues to emerge, the impact of this discovery will undoubtedly shape the future of our understanding of the universe and could lead to a major revision of our current cosmological models. The James Webb Space Telescope, JWST, excels in detecting distant objects in the universe, thanks to its infrared capabilities. Unlike visible light, which is often redshifted when traveling through space, infrared light can be detected by JWST's advanced infrared cameras, enabling it to see farther than any other telescope. However, what happens when something goes wrong with its instruments? If the JWST is unable to detect certain stars, it could be due to a malfunction, but NASA has not reported any issues with the telescope. If stars appear to be disappearing, it might not be an issue with the JWST, but rather with the stars themselves. Perhaps these stars have dimmed or shifted to another part of the electromagnetic spectrum, making them invisible to the telescope. Several theories have been proposed to explain the mysterious disappearance of stars, but none of them alone seem to fully solve the mystery. This has led some in the scientific community to entertain a more unusual and controversial hypothesis: extraterrestrial activity. What if aliens are responsible for these disappearing star systems? The idea of extraterrestrial life has been the subject of debate for years. While some people are convinced of their existence, others dismiss them as fantasy. UFOs and unidentified aerial phenomena, UAPs, have often been cited as evidence, and recent hearings in the US and Mexico in 2023 have reignited the belief in extraterrestrial life. During these hearings, astonishing revelations were made about UFOs and the government's involvement in extraterrestrial technology. However, the absence of tangible proof, such as video footage of live aliens, leaves many skeptical. But if aliens do exist, how could they make a star disappear? One possibility is that advanced extraterrestrial civilizations could be using these stars for their own purposes. One idea is the construction of a Dyson sphere, a hypothetical structure built around a star to harness its energy. Such a device would turn a star into an energy generator or battery for an alien society. Although Dyson spheres are considered theoretically possible, the existence of extraterrestrials remains highly uncertain, and constructing such structures for trillions of stars across the universe would be a monumental task. Therefore, this theory doesn't seem to provide a plausible explanation for the star's disappearance. Meanwhile, JWST has uncovered an alarming anomaly in a distant galaxy, NGC 5584, located about 75 million light-years away. The discovery of pulsating stars in this galaxy, which shouldn't exist, challenges our current understanding of the universe. This revelation suggests that the universe is expanding faster than our cosmological models predict, which directly contradicts the Hubble constant. The Hubble constant is a measure of the rate of the universe's expansion, and its value has been debated by astronomers for some time. The Hubble constant was first introduced by Edwin Hubble, who discovered the relationship between the speed and distance of galaxies. Astronomers have used various methods to calculate its value. One method involves observing distant stars like those in the Andromeda galaxy, and measuring the change in their position over time. Another method relies on the cosmic microwave background, CMB, which is the afterglow of the Big Bang. As the universe expands, the temperature of the CMB decreases, and by measuring this cooling rate, scientists can estimate the value of the Hubble constant. However, these two methods have yielded conflicting results, a phenomenon known as the Hubble tension. This discrepancy has left scientists puzzled, as the difference between the two measurements remains unexplained. In light of these contradictions, scientists may need to reconsider the standard cosmological model, especially in the face of discoveries made by JWST. Planets certainly exist in the universe, but they may exist in forms we can't currently observe. One hypothesis suggests that stars play a key role in understanding this mystery. When stars reach the end of their life cycle and can no longer hold their gases, they explode in a process known as a supernova. During this explosion, the star's mass is scattered throughout space as small particles. What if something similar happened to entire planetary systems that mysteriously disappeared? While this idea is intriguing, most of the scientific community disagrees. Stars don't just vanish without a supernova, and it's unlikely that such a colossal event, involving trillions of stars, would go unnoticed. A cosmic explosion of that magnitude would send shockwaves throughout the universe, potentially impacting our own Milky Way galaxy. This makes the initial hypothesis less plausible. However, another hypothesis has emerged, which suggests that black holes could be responsible for the sudden disappearance of these stars. Black holes are regions of space with extremely high gravity that pull in matter, including light. Occasionally, black holes have been observed swallowing entire stars. But could one black hole consume a trillion stars? That seems unlikely unless there were a multitude of black holes involved, which would make this theory less coherent. This mysterious event has prompted a group of researchers to delve into historical records. One researcher, Beatrick V. Rowe from the Northern Institute for Theoretical Physics in Sweden, is leading an intriguing project called VASCO, which aims to address this mystery. The project involves scanning cosmic archives to find a star that existed from the dawn of the universe but mysteriously vanished at some point in history. If such a star is discovered, scientists may be able to explain why it disappeared and use that insight to understand the current phenomenon. However, up until now, no such star has been found. Despite this, the VASCO project has sparked significant interest from astronomers, researchers, and scientists from various fields. Some researchers believe that a star could have disappeared without leaving a trace, hidden by the vastness of the universe. In this case, the very star that could have been the subject of this research might not have been catalogued at all. Nevertheless, V. Rowe and her team are determined to continue their work on the VASCO project. Another cosmologist, Leo Airy, has proposed that certain stars might be able to die without going through the usual process of a supernova. These stars could directly transition into black holes. Airy referenced an event in 2009 when a star nearing the end of its life suddenly exploded and transformed into a black hole. The event occurred so rapidly that researchers were unable to observe the process in detail. Could something similar be happening now? Interestingly, the James Webb Space Telescope, JWST, has not detected any black holes where these star systems once existed, making this theory less likely. Data from the JWST suggests that stars seem to vanish abruptly and inexplicably, which presents another layer of mystery. Some researchers have even speculated that there may be a malfunction or breakdown in the JWST itself. Perhaps the telescope is unable to detect the light from these stars as it did before. After all, everything visible in the JWST's images is the result of light, whether from stars, planets, or any other cosmic object. The key factor in visibility is the light that reaches us. If an object is billions of miles away but its light doesn't reach us, it may remain undetectable.